All right, what downward force would you need to exert to keep a 14 centimeter radius sphere with a density of 253 kilograms per cubic meter submerged in a fluid with this density, right? Okay, so ultimately what we're going to do is we've got this fluid like this, right? We've got this sphere, right? And notice that the sphere is less dense than the surroundings, right? Okay, so this sphere is going to have a downward force. That's going to be its weight, and it's going to have an upward force, which will be the buoyant force. And the buoyant force will be bigger than the weight, and the reason for that is that the sphere has less density than the fluid that it's in, right? So this would be the buoyant force, this would be the weight, okay? So the first thing we got to do, I think, is to figure out the mass, the weight of the object, right? The weight's going to be mass times g, which is going to be the density times the volume times g, right? And this is of the sphere, right? Density of the sphere, volume of the sphere times g. So that's going to be 253. It's a sphere, so it's 4/3 pi times 0.14 to the third. So 4/3 pi r cubed, right? That is actually in your data packet, okay? Times 9.81. Okay, so we can do this. 253 times 4 divided by 3 times pi times 0.14 raised to the third times 9.81. Okay, so this thing weighs 28.527 newtons, right? So this force is 28.52 newtons downward, right? Okay, the buoyant force is going to be density of the fluid, volume of the fluid displaced times g, right? So the fluid is 965 kilograms. Notice it's the same formula, right? Okay, volume is the same volume, right? 4/3 pi times 0.14 to the third, and then times 9.81, right? Okay, so same calculation I just did, only I'm just going to change the density. That's how lazy I am. Okay, so 965. And so I'm getting that this is, the buoyant force is 108.81 newtons, and that would be an upward force. It would be the buoyant force. It would buoy it up. Boy, oh boy. All right, so this force is 108.81. Right, so what additional downward force would we have to exert? Well, let's figure it out, right? It's got to add to 0, right? So 108.81 upward, right? Minus 28.52, that's the weight, right? Plus the force is going to equal 0, right? Because it's not accelerating up or down. Okay, so 108, that number minus that. And I get that the force has to be negative 80.28 newtons, right? So 80.3, notice it says what downward force, right? So I get negative 80.2, which that means it's a downward force, right? All right.